Okay, so here is the review for chapters 4, 5, 6, 8, and 9. We did 1, 2, 3, and 7, I guess, in the first semester. So this is the second half of the year review. This video, I'm recording this right now, so if you want to watch this again tonight before your final tomorrow, go ahead and do that. Oh, that doesn't seem to be working. Give me a second. All right, so let's get into chapter 5. We're going to start with chapter 5. That's what we did at the beginning of this semester. So we started with chapter 5, talked about polynomials. So we went from chapter 5 back to chapter 4, and again, I'll remind you why in a few minutes. But chapter 5 is a polynomial review. So I'm going to do this pretty quickly. So this is not going to be a teaching lesson, it's just a refresher lesson. So a polynomial is one term or a sum or difference of terms whose variables have whole number exponents, so the exponents are not fractions or decimals. For example, this one right here is 2m squared plus 3m minus 5. And if you guys want to take down some lights here, if you want to shut that light off, if that helps, you go right ahead. Okay, so a single term or a sum of terms. The coefficient is the number that is multiplied by the variable. That's called the coefficient. The number, if there's a number shown that does not have a variable, that's called a constant term. So we've got coefficients are the numbers multiplied. Constant terms are the ones usually written at the end, but they have no variable on them. The degree of the polynomial is the largest exponent that you see on any of the variables in the terms. So 2 is the largest exponent I see on an m there, and so this is degree 2 right here. A monomial has one term. 2 terms is a binomial, 3 terms is a trinomial, and 4 terms is a quadrinomial. You don't hear that one very often, and that's not in the textbook, but we had talked about that one in some of our assignments, so I put that up on the review. So again, if you're madly trying to copy all of this down, it is in your notes, it is on previous videos. You can watch this video a little bit later tonight, but I'm going to do this pretty quick, okay? So algebra tiles, we talked about algebra tiles. You do not have to use algebra tiles for your final. As a matter of fact, you may want to draw algebra tiles as a pictorial representation to help you add or subtract or multiply or divide polynomials. You do not have to. There's no place where you have to, but on the final, be prepared to see some algebra tiles and to know what they mean. Okay? Be prepared to see this right here in the top right corner and be able to connect that with a polynomial expression. So the large squares are like the variable squared, right? So x squared, or in this case p squared. These ones are just the variables like x, or p and p. And then the small squares are just singles, so they're 1, 2, 3. If they're a light color, they're positive. If they're a dark color, they're negative. So this is 2p squared plus 2p minus 3. So just a reminder there. Okay? Like terms is the next kind of important thing that we want to highlight, and that is those are terms with the exact same variable or variables and the exact same exponents on those variables. So 3x squared and 2x squared have the same variable with the same exponents on them, so you can combine like terms. It's kind of like 3 guava fruits and 2 guava fruits, whatever kind of thing. We have 5 guava fruits, so you can combine those. If you have an apple and an orange, like this, here's an apple and here's an orange, well, you can't combine that into one single term because those are 2 different things. They're like unlike terms. So you'd have to keep them separately if they don't have the same exponents on the same variables. Okay, again, moving through quickly, operations with polynomials. When you add polynomials, you simply gather like terms, as highlighted in yellow here. We have 3r squared and 2r squared. That becomes 5r squared. And then 5r minus r is 4r. If we're subtracting, that's where it gets a little tricky. And again, there's a couple ways you could think about that. You could, first of all, rewrite the difference there, okay, or the subtraction between 2 integers. You could rewrite that by making this minus a plus, by switching the sign here to make it a plus. And that means you would have to switch the signs on all the things in the brackets behind that too. So notice how I switched all the signs behind that as well. So you could change it into a sum of opposite terms, okay? I like to do it this way. Again, once you get the hang of this, or once you get used to this, this is what I do. I just do 3r squared minus 2r squared. That's easy. That's 1r squared. And then I say 5r minus a negative r. You see, minus a negative. That's 5 plus 1r is 6r plus 6r. So you don't have to rewrite it, but it's the same as rewriting it as a positive and switching all the signs. And again, if you want to look at the full lesson on that, you certainly can, or talk to me about that later. Yeah, do you have a question? Sorry? This is in chapter 5. I'm not exactly sure what page this is on. This is in chapter 5. These clippings could come from the chapter 5 review, I believe. Yeah.
For questions like that, do we have to show the entire process, I guess, of organizing it?
If the question asks you to rewrite this as a sum, then yes. If it asks you just to simplify, then you just do whatever you need to do to get the right answer.
Okay.
Yeah. Okay, that's fine. Multiplying. Okay, so if we have a monomial times a binomial or a trinomial or anything more than one term, then you would take this number and you would distribute the multiplication in. So 2t times 5t is 10t squared. Make sure you add the exponents for variables when you multiply. 2t times negative 3 would be minus 6t. So you have to distribute. You have to multiply the first one by everything that's inside the brackets and then write that product as separate terms there. Okay? Dividing as well. So if you have a polynomial divided by a single monomial term, that's the same as rewriting each term up top divided by that single term on the bottom. So you could do it that way, and then simplify each of these separately, and that's your result. Okay? So that's how we divide. And that's chapter 5. Right? So chapter 4 was what we did next, and again, I switched the order a little bit of the textbook because this is just a little bit more broad, and this is like almost creating the equations, which I thought once you know what a polynomial looks like, now generating a polynomial graph and all that sort of stuff might come a little bit easier. So we are describing patterns and writing equations that describe patterns. So let's talk a little bit about chapter 4. And again, these are worksheets that we've done already. I have videos on this. We've learned about this. You should have these worksheets even returned to you from months ago. But let me just go over a few questions just to highlight some important things. So in each equation, determine the value of a when n is 3. So that'll be a type of question you might get. If you substitute 3 in for the n, then you just solve for a, or you determine what a is. And I did letter a over here for you. So a equals 2n plus 1. And if I substitute 3 in for the n right here, then that's 2 times 3 plus 1. That's 6 plus 1. A is 7. So it's a simple substitution there. Solve for the missing variable. Another thing we have to do in chapter 4 is to determine an equation given a table of values. And so what you want to do here is you want to focus on the difference between each of the numbers that are shown in the table. And here it's a plus 1. And the difference in the numbers that are shown on the right side of the table for like the y value or the dependent value, the variable. And this is adding 3 each time. So if you find that, making an equation is actually really easy. You go positive 3 times this variable over here. So 3n. And then you're going to have to make one slight adjustment. You might have to plus or minus some term over here to let this equal p. Okay? So 3 times n equals p, but there might be some kind of adjustment, and that adjustment comes here when I try this out. 3 times 1, does that equal 7? No, 3 times 1 equals 3. So what do I add or subtract to get up to 7? I add 4. Okay, so that works for the first one. Let's see, that should work for all of them. So 3 times 2 plus 4, does that equal 10? Well, that's 6 plus 4. Yeah, that does equal 10. And this should work for all of these, which means that we have an equation here that we've made, and that is 3 times n plus 4. And that's our equation. Okay? So that's how you build an equation from the table of values there. 3n plus 4 right there. Okay? All right, just a couple notes here again. This is a whole hour lesson, so I'm not going to go through all this, but describe the pattern the pattern is not an equation, it's just a relation. So if you see that wording on the test, describe the pattern, it's not the equation, it really only involves one variable. And the equation would involve both variables where you actually have the equal sign in there, okay? So there's a little difference between the expression or the pattern and the equation, okay? So I won't go through this entire word problem, but if you want to, pause this and take a look at this question number 4 and what I've done with the graph over here to come up with this equation, then you can do that now and take a little closer look at it. All right, next page, linear relations. Okay, describe whether each of these table of values has a linear relation or is a linear relation. Again, what you're looking for is a consistent increase or decrease over here. So this is +1. And you're looking for a consistent increase or decrease between all the numbers on the right side as well. And so this looks like it's +7, right? So that is a linear relation. This is yes. D over here is not. Why? We do have a consistent +1 over here. But this is -12, this is +7, then this is +5, then this is +3, then this is +1. Do you see how that's changing? So this is not a linear relation. They both have to be consistent, okay? Now, if you do have questions, you can ask for sure. I will answer them if I can, or if it's a big question, I might have to just talk with you later about it. Okay, filling in values in a table like this is going to be pretty important as well. Check this out. This goes up by 1, and this one we know goes up by 4. So if it's a linear relation, that must hold true for all of the rest. So if this is +1 here, then this also has to be +4. So that means that this would be a 10. So 2 goes to 3, 10 goes to 14. So in essence, we're subtracting 4 from each one, and going up, we're adding 4 from each one. And so you would fill in the table like that, so it's consistent. Creating a table of values, that's very, very important, and I hope that you all know how to do that. If your variables are x and y, make a column of x and a column of y. You can pick any numbers for x, or if they give you the numbers that you should pick, then this is what you do: -2, -1, 0, 1, 2. And then you simply substitute those values in for x and write the resulting y value right beside it. So let's do the first one. -2 plus 4 is +2. So we put a 2 over there. Again, -1 plus 4 is 3. 0 plus 4 is 4. And then you notice the pattern here. Look at that, it goes up by 1 each time, looks like. So we're going 2, 3, 4. So 1 plus 4 is 5, 2 plus 4 is 6. So there would be your table of values for A. Okay, what about from this page? Again, I know I'm going real fast, but this is just a review for you. Okay, this is a good question. Does the equations below represent a vertical, horizontal, or oblique line? So vertical is straight up and down. Horizontal is straight sideways like this, it's a flat line. Oblique is any kind of slanted line, okay? Any kind of slanted line that's not straight up and down or sideways. It's another name for that would be a slanted line, okay? So oblique is same as slanted. And yes, these terms, you do need to know these terms for the final tomorrow. So if you're not remembering these, you need to look them up. Put them on your cue sheet if you want. You can have a cue sheet for this test tomorrow, so put them on your cue sheet if you're in my class here. Now, y equals 4. So how do you know the difference? A horizontal line is y only in the expression, y only. So this is right here, horizontal. This right here is also horizontal because it's y only. The vertical is x only, x only. And so this term has an x only in it, or this, equation has x only. And oblique or slanted will have x and y terms in the equation. So that's this one right here. Okay. Okay, this is a horizontal line that passes through y equals 2. So guess what? It's y equals 2. This one right here is a vertical line that passes through x equals -2, so x equals -2 is the equation of the line. Okay, so more table of values and graphing. Again, table of values and being able to graph, pretty important. Okay, graphs and equations, yeah, let's do this one right here, number 4, because they're all kind of the same in this assignment. So in order to match a graph with its equation, first thing is, good idea to have the y isolated all by itself. So get y all by itself in positive on one side of the equation, then all the other terms on the other side. Because this is an important format. Y equals mx plus b. Do you guys remember that one? Mx plus b. The m is the slope of the line. So whatever number is multiplied by x is the slope. And whatever number is the constant in this equation is the y-intercept. So we can build an equation pretty easily from the graph, or draw a line from the equation pretty easily knowing just these two things. So we have a y-intercept of 2 here. See that? The line intercepts the y-axis at 2. That's the y-intercept of 2. So b is positive 2. And the slope, now zoom in here, the slope is between any 2 points that you can spot on the line that you know for sure what they are, the rise to get from one point to the next, divided by the run, or the distance sideways to get to the next point. If you divide those two numbers, you get the slope. So in this case, always work from left to right, always left to right. I go up 1, 2, and I go to the right. Whoops, wait a minute. This is, yeah, they're all 1 square, good. And then I go to the right, 1, 2. So rise is positive 2 going up, and to the right is also a positive 2. So the slope is 2 divided by 2 is 1. So my m term is 1. So my equation becomes y equals 1x plus 2. Or we don't usually put 1 as a coefficient, just x plus 2. Any questions there? So it looks like this one right here. Okay. Now if for this second one, the negative number on the x is a -1 slope. So instead of going up 1 over 1, up 1 over 1, we go down 1 over 1, down 1 over 1. So it's a slope this way. Okay? It slopes the other way. All right. Oh, that's not the end. Okay, I thought this was the end. Using graphs to estimate values, perfect. Let's see. On this graph here for number 2, I'm going to show you, determine the value of x when y is 3. So what we do is we find y equals 3, which is right here, and I find the line. Oh, the line is over here, so this is right in the horizontal row for y equals 3, and I just drop straight down to get the x value, see? So when y equals 3, x equals 1. Now, when x equals 0, so where's x equals 0? X equals 0 is right here. So I got to find out what the y value is. I go up until it intercepts the graph, and that is y equals 1. So they're always partners on the line. One is a y value, and one is an x value. So if you know the one, you can always find the other. Okay? This is all coming back to you? Is it coming back to you? Okay. I know I'm going super fast. I know I'm going super fast. I believe in you guys. Okay, another thing I'll just mention here on this page, if you have a word problem like this where you have some kind of flat fee or some kind of starting fee, that would be your y-intercept on the graph. Okay? So in this case, if you look closely at this graph, with 0 minutes of long distance calling, you already owe, what is that, 20 cents? 0.2? So you already owe 20 cents. So as soon as you start to dial, 20 cents, boom. Doesn't matter how long 20 cents. And then the slope of this would be the rate of cost per minute. That's the slope. Okay, so you can find out from a 5-minute call, you go up to this graph and you go over, and that looks like about 45 cents that you would owe, let's say. For a 10-minute call, you would owe about, what is that, 50, 60, 75 cents, and so on. Okay? Any questions there? Okay. Let's keep moving. We got a little bit to cover here. So what is this? Number 6. Okay, equations. Equations. So solving equations is basically finding the missing variable value. So this is a very simple equation right here. I have x equals 2. Well, what's the value of x? Well, it's equals 2. You don't have to do any work to find out what x equals here, right? Over here, you might have to do a little bit of work because 2 times something equals 4. So 2 times 2 equals 4. Over here, looks a little bit harder, but some number divided by 2 equals 1. And of course, x is 2 here as well. So these are 3 different equations where x equals the same number, and that is x equals 2. In order to solve an equation, what you want to remember is opposite operations. That's the way I teach it always. Opposite operations. So if you have some kind of equation where you're trying to find a variable that's stuck inside an equation, you want to do your order of operations in reverse order to try and get all of those other numbers separated from the variable. So in this case, look at this equation of r divided by 4 plus 3 equals 7.2. So I would start with subtraction and addition first. So here's an addition on the right side, on the left side where the variable is. So I would subtract 3 first to get r over 4 equals 7.2 divided by 3. What's that? 3, 12, 2 point something. So 2.4. So we've done that. Now we do multiplication division. Well, r is divided by 4, so let's do the opposite of dividing. Let's multiply by 4. And so the 4's now cancel out on this side. 4 divided by 4 is what we have over here. And we have r equals 2.4 times 4. So what's 2.4? Oh, sorry. This 2.4 is incorrect. I am not dividing, I am subtracting. I'm not sure why I said dividing. So let's just back that up a bit. 7.2 minus 3 is 4.2. There we go. Times 4 is 4.2 times 4 is 16.8. Okay, 16.8. There we go. Now we got it. Subtraction. Okay, common mistake. Okay, so on the right side over here, yeah, we have, oh, there's the 4.2. 16.8 is the correct answer over there. And these are the two sort of methods. We didn't really do this one very much in class. You are familiar with this graph, but we didn't really work on this. We mostly did the opposite operations. Okay, so opposite operations would get you to 16.8 there. And it would be a good idea to check. Remember, I encourage you to check each thing that you did. So 16.8 is your answer. So if you put that in for r, this side should equal the right side, which it does there. Okay, any questions? All right. Here's a couple examples. I'll just show you. If you are solving for r, so add 3 to both sides to get 10 on the right side, and then divide by 2 to get 5. Subtract 10 from both sides to get 4. Multiply by 3 to get r equals 12. And then if you check each of those numbers, the left side should always equal the right side. Okay, we need to talk about inequalities here as well. You guys are trooping along here. Good job. So inequalities very much the same as equations, except for inequalities is there's a range of numbers that would be the solution to an inequality. Can we grab that window maybe? Can we shut that down? I'm not sure if the air conditioning's keeping up. It's getting warm out there now. Pull down hard. Muscles. It's twisted a bit. Pull the left side down first. Sticky old windows, that's okay. All right, so an inequality has a range of numbers that would be a solution. So think about this. Let me start with equations here. Let me start with equations. X equals 2, great. We know that there's one solution, and that is x equals 2. But if I do something like this, that means x is less than or equal to 2. And I always remember this. this makes an L, so it's like less than. If you read it from left to right, that's like an L less than. So anything that's less than or equal to 2 is a solution. So here, I mean, x could be -5, x could be 0, x could be 1, or x could be even 2 itself, but there's a whole list of answers. If you had an inequality and you were solving, everything is the same except for one little hitch. Do you remember what the one different thing was? Let's say, okay, something to do with the sign, yes. So let's say that this was the inequality and I'm trying to solve. If I do everything the same as an equation, which is a great idea to do, divide both sides by -2, and I get x less than or equal to -2, but this is incorrect. So what you have to do to adjust for that is when you multiply or divide by negative, you flip the inequality sign. So now this is the answer, and if we check that, 0 would be greater than -2, so -2 times 0 is 0, and that is less than 4. That's one that works. So you can check all of those, and that will work each time. So multiplying or dividing by a negative, flip the inequality sign. The graphs, you'll see some of this on your final, right? If we have this graph right here, the solid dot means it includes that answer. So including, okay? So this is the variable, whatever it is. In this case, it's f is greater than, because it goes to the right, or equal to 3.5. The open circle means not including. And so this graph over here would be f, or g in this case, is less than -7/4 is the value there. So just less than, no, or equal to. All right. Okay, so how many so far in this review are like 5 out of 5? All of this looks totally familiar. I get it. I know all this stuff. I'm going to ace this so far. Anybody less than 5 out of 5? Show me a number. Where are we feeling? Some 4s. Okay, I'm seeing a lot of fingers, so that's good. That means you're remembering this stuff. Okay, excellent. I'm really happy. So again, same thing. When you divide by a negative or multiply by a negative number, you have to flip the sign. And I won't go through the explanation of that just to save some time here. But yeah, that's just one of the rules and one of the patterns that are discovered in math that we have to do. Okie dokie. So yeah, there's some more examples, but I don't think I'm going to belabor it. This one right here, though, you might want to take a look at. If you get a complicated inequality, complicated means that, hey, you might have to do some multiplication and simplification here first. So letter B is maybe a trickier type. You have to distribute that 3 to get separate terms. Then you have to gather like terms. So if you add or subtract, you don't flip the sign. Only if you multiply or divide by negatives do you flip the sign. So you can gather like terms and move things over to the left and right of an inequality just the same as an equation. But when you divide or multiply by a negative, that's when you flip the sign. And notice we didn't multiply or divide by a negative at all here. We just divided by a positive 8. So you don't flip the sign if it's a positive, okay? If you divide or multiply by a positive. All right. All right, moving on. Let's take a look at chapter 8. Chapter 8 is the circle geometry one. So I'll go over just a few of the highlights from chapter 8. A tangent to a circle. Hopefully you remember what a tangent is. A tangent is a line that touches the edge of the circle just once. It does not go through the circle at all and touch more than once. No, it only touches at one point, and this would be the point of tangency is what it's called. Now, if a great thing about the point of tangency and the tangent line is that any line connecting the center and the point of tangency forms a 90-degree angle with the tangent line always. So that's always true. If I drew another one over here, anywhere over here, and drew this radius right here, and I drew a tangent line to this point of tangency, that would be 90 degrees exactly if I drew that properly. Okay? So, if you have a question like this, and I've done it for you here, so you don't have to do this, just look at the answer here. This is a 90 degree because this is a tangent line and that is a radius. So this is a 90 degree. That means that 54 plus 90 plus y has to equal 180. You can solve then for y. Y has to be 36. 180 minus 90 minus 54. Questions? All right, here's another thing. A perpendicular from the center of a circle always bisects a chord, or a chord that is bisected is always a line that goes through the center of the circle. So this arrangement is always true. Any chord that's a line that is a straight line that goes from one edge of the circle, or one part of the circle to another part of the circle, if you draw a line through the center, it always makes a 90 degree, and it always B cuts this in half. So any chord that I draw, let's say I draw this line right here, well, this distance between those 2 points will be exactly cut in half if I'm careful to draw a 90 degree angle through the center. If that's 90, then this side is the same length as this side. So those things are always true together, which helps us to solve questions just like this one. 16 is a chord that is a special chord that goes through the center. What's the special chord that goes through the center of a circle called? A diameter, right. And so the radius is exactly half the diameter. This is 8 from center to edge. Now I can make a right triangle to solve for x here, watch closely, if I connect the center to this point, oops, that's a bad line, center to this point right here where x connects the circle there. So I have a little right triangle here. I'll redraw it over here. 7 is this part, x is this part, and I know what this is. What's the length here? 8. That's right. So x, so you can do 7 and x are the legs of the right triangle. They form the 90 degrees. So 7 squared plus x squared equals 8 squared. What theorem is this? Pythagoras. Yeah, Pythagoras. Good job. Pythagorean theorem. So I can solve here now. Let's see. I'm going to write this as 49. I'm going to write this one as 64. I'm going to subtract 49 from both sides. So I have x squared equals, what's this now? 49, so what's that? 15? 15. So the square root of x squared and the square root of 15, it's going to be x equals, what's the square root of 15? That's going to be 4 point something on your calculator. You will be able to have a calculator for tomorrow's test. There may be a few questions where I'm asking you to do without a calculator, but for the most part, you should make sure you bring a calculator and all necessary materials to your final exam. That is pencils. Bring a couple in case a lead breaks or something. Pencils, eraser. There's no pen on the final. Okay, you cannot use pen on the final exam at all. You have to have a pencil. So pencil, eraser, geometry set, ruler. That's optional for you if you want, but make sure you have a calculator. Okay, make sure if you don't have your own, borrow one. So the square root of 15. Let's see here. Let's get out of here. Clear this. The square root of 15 is 3.87. So 3.87 or so. Okay, so that's going to be our x value there. Okay, I mentioned this already. Perpendicular line to any chord always passes through the center. There are some related questions which I won't take the time to go over. If you want to watch this video later and pause this and look through this question, feel free. But you can solve for these angles x and y, because both of these are radii right here and here. These angles have to be the same, so x is 35 because it's an isosceles triangle. And then 180 minus 35 gives you y. Yeah?
Just about what we need on the final. Are we going to need to bring a compass or a ruler?
The measure of a central angle subtended by an arc is twice the measure of the inscribed angle. So watch this. If we have two angles, one being a central angle and one being an inscribed angle, and they both intersect the circle at the same point, that is, they subtend the same arc, then this is always twice as much, twice as big as this one. So this is half the size of the central angle. So in this case, if this is 120, well, I have an angle here that subtends the same arc as the central angle. So x is 60 degrees. It's half. And even though it may not look like it, this y value also is an inscribed angle that subtends the same arc as the central angle 120. So y is also 60 degrees. Okay. Now if this is 240 right here, okay, if this is 240 and I have an angle like this, okay, so this is the arc that we're concerned with right here. That's the arc. This is a central angle. This is an inscribed angle that subtends the same arc. So this might look a little funny, but if this is 240, this has got to be half that, 120. So that's a bit weird one. The arc is more than half the circle, but that still works. And what's the other thing that we said about? I guess this is maybe comes. I don't know if I have an example for this. Bad circle, sorry, but if you have a quadrilateral that is inscribed in a circle, do you remember the relationship between these opposite angles? They have to equal 180. I believe that is true. Why? Because 180 plus 180 is 360, which all the angles have to add up to. So yeah, opposite angles are supplementary in this case. Okay, so those angles are supplementary. They add up to 180, and that might help you. We talked about that too in this section. Okay. 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 Special case. If you have a central angle that's 180, and that is a diameter, okay, any inscribed angle here would be half of 180 or 90.
Please come to the main office.
Okay, I'm kind of running out of time here, so I'm just going to do this. I'm just going to show this question here real quick. You might get a question just like this where you'll have to spot and use these properties. So 122 is the central angle here, and notice that x is an angle that subtends the exact same arc as 122. So x is going to be 61. Okay. Y, look at this. This is a diagonal, or a diameter, and so y is going to be 90. And then you can solve for z. We know we could find out. Let's see, how do we do this? We could find out what f is, because f subtends the same arc as this big angle, and so it's half of this larger angle, which is 238. So half of that is, this is 119, 119, and then you could find z that way. Okay, I have 2 more minutes. I'm going to quickly do chapter 9. This is going to be very quick. We just did chapter 9, so it's fresh in your mind. Probability, couple things. I won't go all over this. You guys can watch the chapter 9 review if you want a little more detail. Please know the difference between theoretical probability, that's based on the nature of the situation, or experimental probability, that's based on actual trials or experiments, what the probability is expected to be. Know the difference between subjective and objective. Subjective is based on personal beliefs. Objective is based on data alone, without personal beliefs being involved in the decisions.
Can we put those definitions on our?
Yes, you can put definitions on your cue sheet. 9.2, please review all the problems or potential problems with collecting data. You all did a project, a survey, an experiment. So you went through all this just recently. These are the problems that you may occur. Also, we put in here what? Audience. We also added audience and what? What was the second one that we added there? Subjectivity? Yeah, it was subjectivity? Okay. So audience and subjectivity would be 2 more things you should consider. 9.3, okay, a sample is a small portion of a larger group. The larger group is called the population. If you test everything or every person in the population, that's called a census. You want valid conclusions when you take a sample, so make sure your sample is large enough. Make sure it's free from bias. And there are different types of samples, which we talked about in 9.4. Simple random, self-selected, systematic or interval, convenience, cluster, and stratified. So please review those definitions as well. We talked a little bit about your project there. We talked about rubrics and things like that. So this is all fresh in your mind, so I'm not going to cover this as in detail. But anyways, that's your quick review for your final for this semester. And again, that's was that chapters 4, 5, 6, 8, and 9. If you're in my class here, that's what the final's on. Any final questions in the last minute before the bell rings here? All right, make sure you study hard tonight. No video games. You guys listen to me? No video games. Studying hard.
Rowena brought this in. I think this is probably for Devos, or I'm not sure when, but they got to fill out these checklists, you know.